Welcome back, class. Today we're going to start a section on solving rational equations. So we've been doing all of this work on rational expressions, how to multiply, divide, add, subtract them. Now we're finally going to get into the solving piece. How do I solve a rational equation? So a rational equation contains at least one rational expression. You can solve a rational equation by clearing out the expressions in the denominators. Caution. You always want to check for extraneous solutions, that would make you divide by 0 in the original equation. So if when you get a solution, if you put it back into the equation and it would make you divide by 0, that means you can't actually use it as a solution. All right? Now today we're going to talk about two main strategies to solving these things. Our first strategy. If you have two fractions that equal to each other, you can use cross multiplication and solve from there. So this is something I know we did back in Expo, and I'm not even sure, maybe earlier than that. But if you just have two fractions set equal to each other, all you have to do, cross multiply. So 5 times x plus 2 is going to equal 3 times 2x minus 1. Now you just have something linear that you can solve. So I'm going to distribute the 5x plus 10, distribute the 3, 6x minus 3. Now we have to bring the x's together. So I'm going to subtract the 5x from both sides. So 10 equals x minus 3. Then add 3 to both sides. X equals 13. And if you go back to check it in the original equation, well, since both denominators are just a number, there's no risk of dividing by 0, so you don't really have anything to worry about in this case. So, cross multiply here, 7 times that x plus 1 is going to equal 2 times that 2x minus 4. And again, we need to distribute 7x plus 7 equals 4x minus 8. Now let's bring them together. So I need to subtract 4x from both sides to bring it over here. So I'll get 3x. Need to subtract that 7 off. So 3x will be negative 15. Divide by 3, x is going to equal negative 5. All right, and again, this strategy you've seen for a while now. You've done this for a while, just simple cross multiplication. Now, the strategy that's more interesting, the one that we're going to focus on more today, is if the rational pieces of an equation are being added and subtracted, then multiply every term of the equation by the least common denominator. This should eliminate any fractions. Then solve this easier equation. All right. So what I mean is I need to look at the pieces in my denominator. So now I have an x down there and I have a 5x down there. So what I'm going to do is I'm going to multiply the equation by the least common denominator to eliminate all the fractions. All right, now what that means is in this case, I'm going to have to multiply everything by 5x. Okay, I'm going to multiply every piece of this equation by 5x. All right, because that's my least common denominator. That'll remove everything from my denominators. So let me show you. So when I take the 5x times the 1 over x, the x's cancel out, x divided by x. So all I have left is 5 times 1, which gives me 5. When I have 5x times the 6 over 5x, well, this time both the 5 and the x cancel out, and all I have left is 6. 5x times that 1 will be 5x. So again, by multiplying every piece of the equation by that least common denominator, it eliminated my entire thing, eliminated every fraction. So now I'm free to just solve. So I subtract the 6x, So negative 1 equals 5x. Divide by 5. You get x is negative 1/5. All right. So let's look at this next one. 1 over 6x squared equals 1 over 2x plus 7 over 6x squared. All right. So let's look at those denominators, shall we? Now here is not quite as easy as the first one, but it's still not too difficult. Because if you think about it, if I multiply by 6, 6 will take care of the 6 and the 2. The 2 will be removed from the denominator as well. So my least common denominator has that 6 in it. Between the x squared and the x, if I multiply by x squared, again, that'll also take care of the x squareds, and it'll actually take care of the x as well. So in this case, I can multiply everything by 6x squared. And let's see what happens when I do that. Well, on this one, it completely cancels out. 6x squared divided by 6x squared, and I have 1. Now, for the next one, 6x squared, and now I'm only dividing by 2x. Well, 6 divided by 2 gives me 3, and x squared divided by x, there'll be a leftover x. Then, of course, there's that 1 there, but we don't really have to show that 1, okay? But again, that's what the LCD is important, because it actually did away with that too, just sometimes it will have some leftovers. Then 6x squared times 7 divided by 6x squared. Well, the 6x squareds perfectly cancel off. So all you have left is the 7. Now you just have something linear that you can solve. Subtract 7 from both sides. So negative 6 equals 3x. Divide by 3. You get x is negative 2. All right. In our next one, again, we're focusing on the denominators. To what do I need to multiply to get rid of them? Now this one's really easy because it's the same thing in both denominators. So clearly, we're going to have to multiply everything by 5r. All right. Now, on these sides, it's easy because that 5r will just cancel out that 5r. So that'll leave me r minus 4. Well, that 5r perfectly cancels that 5r. So you just have 1. The only one that sticks around is that 5r times 1 because there's no denominator to cancel any of it out. So that's the only 5r that actually stays. Now, again, we have something linear that we can solve. So I'm going to subtract an r from both sides, which will give me negative 4 equals 1 plus 4r minus 1 from both sides. So negative 5 equals 4r. Divide by 4, and you get r is negative 5/4. All right, now, so far we've only been working with monomial things in the denominator. I want you to keep in mind that you can also multiply by binomial expressions. So look at the next one, where it has those n minus 1s in the denominators. So this time now, I need to multiply by n minus 1 everywhere in the equation. Okay, so I'm going to multiply every piece. Oh, sorry, by n minus 8. I apologize. So I need to multiply every piece of this equation by n minus 8. Now, for the most part, it cancels off because this piece cancels off to give you 1. Now, n minus 1 times negative 1. That one, no piece of it cancels out, right? There's no denominator there to cancel it. Then here, that n minus 8, n minus 8. So all that's going to be left is that 7. All right, again, now left with something linear that we can solve. So I'm going to distribute that -1. I'm going to combine my like terms. I am going to subtract the 9 from both sides. And then divide by -1, and that gives me an n of 2. So again, the big idea of this one is just multiplying everything out of the denominator so there's no denominator left. That's the big picture when dealing with these ones. All right. Now, an important word problem for us to do. You work in a pharmacy that mixes different concentrations of saline solutions for its customers. The pharmacy has a supply of two concentrations, a 0.5% and a 2%. That function gives the concentration of saline solution after adding X milliliters of the 0.5% solution to 100 milliliters of the 2% solution. How many milliliters of 0.9 or 0.5% solution must you add for the combined solution to have a concentration of 0.9%? All right. So basically, the first thing we have to understand is what these variables are representing. All right, so X is representing the milliliters of that 0.5% solution. Okay, Y is the combined concentration. The concentration of the mixture. All right. So that's the first thing we have to understand about this problem is that's what these variables are representing. Because you can't pick that up out of this because I know it's wordy, but if you can't pick that up out of it, then there's going to be a lot of issues later on. All right, so now that we have that piece out of the way, now we have to decide what we're being given. Well, we're being given that they have a combined concentration of 0.9%, and we want how many milliliters of the 0.5% do we need? So we're being given Y and we're finding X. That's what I'm taking out of this word problem. All right? They're providing us with Y, they're providing us with a combined concentration, and we want to know how much of that 0.5% one do we need. So if they're giving us a combined concentration of 0.9%, again, keep in mind, back from chapter 7, we can't use percentages in equations. So we have to turn this into just a normal decimal. So we move the decimal over twice, and that turns into a 0.009, all right? Because again, we can't use percents. So we turn it into a decimal. And again, that is going to be my Y value, okay? That's my Y. So I'm going to plug that in. So 0.009 equals, then they have 100 times 0.02 plus X times 0.005, 100 plus X. All right. So now we want to solve this. Well, the cool thing is we can actually solve this algebraically. It may look really messy, but all the algebra that we need, we already know. So I'm going to multiply that 100 plus X. I'm going to multiply that over to the other side. Okay, I'm going to multiply both sides by it to get it out of my denominator. And then that 100 times 0.02, that's just a number. That's actually just 2. And then X times 0.005, we would more commonly write as 0.005X. All right. Now I'm going to distribute that 0.009. So 0.009 times 100 is 0.9, and then 0.009x excuse me, equals 2 plus 0.005x. All right, so now while we're dealing with some small numbers, again, it's doable. All I need to do is subtract off 0.005x from both sides. I need to combine my x terms. Excuse me again. I apologize. Then I'm going to subtract off my 0.9 from both sides. 2 minus 0.9 gives me 1.1. And now divide by 0.004. It would take 275 milliliters of that solution to create that specific concentration. Now, I will tell you that this question is likely to be on your test. So I would make sure you write all these steps down. This is one of those word problems you are going to have to thoroughly understand. Okay? So that is going to be all for our notes today. I thank you for joining me. And then come back ready tomorrow to continue doing your practice work.